Today we're going to look at how to find the lateral and total surface area of a prism. Now, our definition of prism that we're going to work with here is just two bases of any shape. In this case, we see a triangular prism, and those are connected by rectangles. Now, prism does go a bit beyond that, but that's what we're going to work with for today. So first of all, if we were to take this prism and split it right along this edge right here, and then fold it open. So we're going to split along here, and here also, and here, and here. We fold that open. The shape we get is something like this. This is called a net of the figure, and it gives a view of what it would look like if you take it and flatten it out. Maybe you have a box laying around the house, and you can kind of experiment with this idea. The key thing here is that we really have the two bases and a big rectangle. The area of the big rectangle is what we refer to as the lateral surface area, the surface area that does not include the bases. And since it's a rectangle, we can find that area by just taking the regular formula for the area of a rectangle. So we're going to call this L for the lateral surface area, and it equals the length of that rectangle, which if we were to fold this back up, we would see that the length of the rectangle here, it has to fit around this triangle. So that is just the perimeter of the base, P, times the height of the prism, and the height of the prism and the height of the rectangle are the same thing. So that's going to be, we're going to call that capital H for the height of the prism, which is the distance between the two bases. To get the total surface area, T, we just have to take that answer and add into it the area of the two bases. So we're going to write that formula as 2 times capital B, where B represents the area of the base, whatever shape it might be, and plus the lateral surface area would give the total surface area of that figure. So let's look at finding the total surface area of the prism given here. We'll start by finding the lateral surface area, and the lateral surface area requires that we know the perimeter. So to find the perimeter, we need to know the length of this hypotenuse, and that's where we're going to use the Pythagorean theorem. So we're going to have a squared plus b squared equals our hypotenuse squared. So that would be 27 squared plus 17 squared is c squared. Squaring the 27 and the 17 gives 729 plus 289 is c squared. So c is going to be the square root of those two things added together. That is the square root of 1018. Which is approximately 31.9. Now that we know the value of the hypotenuse, we can go on to find the lateral surface area. So the lateral surface area is the perimeter. So adding the 17, the 27, and the 31.9 gives a perimeter of 75.9. So the lateral surface area is 75.9 times 20. That then gives us a lateral surface area of 1,518. Continuing on to find the total surface area, we have that T equals 2 times capital B, the area of the base, plus the lateral surface area. So that's T equals 2 times, well, we've got to find the area of that base. the base is a triangle, so we're going to take the formula for the area of a triangle. So capital B is 1/2 times 17 times 27, which gives us an area of the base of 229.5. So plugging that in, we have 2 times 229.5 plus the lateral surface area, 1,518. And working that out, we get as our final answer. So our final answer for the total surface area is 1,977, and that would be square units. Don't give us any units here, so we'll just leave it like that. At this time, you should turn in your book to page 651 and work numbers 6 through 8 and 11. Have a good rest of the day.